then we'll go out and do a tour of the equipment for those who are okay to go up to the roof. It's okay if you're not. We'll cover those pieces and then talk about the individual pieces of it. But I wanted to give kind of an overall view for everybody of what's involved. And we'll also take a look at the monitoring system. So there is a monitoring system for production, for alerts. We've set up accounts for Jamie and Tom, but we can set up accounts for anybody else for any other information that we want to share with that. So we'll just start with the overview. So this is the home here, as you can see. We've basically, each of the sort of hatched roof areas are the roof areas with solar panels. So we kind of optimized for southwest, southeast facing, just the way the home is positioned. And so it's really actually a collection of smaller systems. So there's 8 separate inverters, which is the sort of main power conditioning unit that takes the DC power from the sun and inverts it so it's on the grid. This system is fully grid connected, which means if the power goes out, the system won't produce any energy. So that's when you rely on your backup generators. So it's designed to be a net metered arrangement. So what that means is that when there's more solar being generated than the building's using, like we'll probably get today, energy will flow back out to the utility, and Hydro One will increment credits that then can be applied to future energy bills. During the winter, the opposite happens. You don't generate as much, and so you'll use those energy credits month to month. So for the first few months, there might be some just check-in that we want to do to make sure that the credits are incrementing properly and that the system is being tracked from Hydro One's perspective. They're pretty good. They've got thousands of net metered systems now, but we always find the way the accounting works is always a piece of the puzzle. So on the flat roof portion, so this is the flat roof part. There's 4 groupings of equipment, kind of at each wing. And so at that point, there are 2 inverters. There's a transformer that steps it up to the 600 volts that the building runs off of, and some isolation disconnects. So there's 4 kind of individual groups of inverters. So the total capacity of the system is 400 kilowatts AC. So each inverter is 50 kilowatts. That's not that important. It's more important to know what it should be peaking at and how it's running. And so in the SolarEdge software, which is the inverter manufacturer, we can set up a performance model. So we've got a prediction of what the system should do, and we'll populate that performance model. So if there's a big variance, you should get alerts that say, hey, the system's not producing. Or if there's issues with the inverter, or if there's issues with the equipment, it'll generate an alarm, which will send an email to whoever you want to send emails to, basically. So, any questions on the first part? Is everyone familiar on the basics of solar? What's involved?
Sun good.
What's that? Bad. Sun good, cloud bad, yeah. So essentially there's these individual panels. In the case of your project, each panel that you see up on the roof is 610 watts. 3 of those would run a hairdryer, if you want to think about that in terms of the context. So it's a fair bit of wattage that's up there. Your arrangement is flush mounted to the standing seam metal roof, and so we actually were able to hit almost 90% output in December when we did testing. So your system's really optimized for peak production, and it's able to shed snow once the sun comes out. So you will get some snow buildup, especially in some of the valleys, like where the snow can't totally slide off. But for the most part, we found this winter, even without it running the whole time, it was shedding the snow quite effectively. So you should never go up there. You should never have to clear the snow. That's not typically required. The maintenance activities, for the most part, happen at those inverter groups at each of these sections.
So that's what group? You said something group?
Oh, the inverter groups. So they're sort of, oops, that's not my intention. Try that again.
That's what you said, mostly.
Maintenance.
Thank you.
So there's sort of 4 areas, and we'll go take a look, for those of you who are comfortable with the stair tower, we'll go take a look at what that looks like. That power then comes back from on the roof, so the panel itself generates direct current or DC. That's sort of like what you have in a battery, or you might run a flashlight with, but high voltage. So it runs at about 600 volts. That's the peak voltage. Because this is a residence, we are capped at 600 volts. Commercial systems can go up to 1500 volts DC. But for the purposes of this being, I know it's institutional, but these are homes, this is residential. That was the ruling that we based that on. And so what happens is all that power comes back and it runs into this combiner panel here. So you can see these 4 conductors. These 4 conductors go from each of those corners of the roof and bring the power to this combiner panel. Now this panel is, as we call it, dead front, so we can open it while it's running. And there's essentially a breaker for each wing of the array. So this is combining all that power. So each one of these is about 100 kilowatts, and in total it's 400 kilowatts that are coming into this panel. Now from this panel, if anyone wants to take a closer look. So Tom had emailed me about infrared imaging and having a maintenance program related to that. This is one of the panels that would be part of that. Basically the system gets turned off, the covers come off, it gets re-energized, and then once it's warmed up, you do infrared imaging. So there is some coordination around what's happening in the area to accommodate that. But essentially this power flows from this panel directly outside. So all that power gets combined and it comes, I won't open this because this is live and there isn't a dead front on it. All that power gets combined and comes into here. This is the emergency disconnect. So if there ever was an emergency, this is the switch to turn it off. I'll show you another softer way to turn it off if you need to, but this is essentially the utility isolation. So if there's an emergency at the building and they need to isolate the solar, this is the disconnect switch that they'll turn. It's adjacent to the metering because they always want to know where it is, and it's got to be lined up tight to a transformer, which is what the distinction. This is a bigger enclosure because it also includes some of the monitoring control equipment for Hydro One. So because it's of the size of system and the fact that we're connected to a lower voltage feeder, there is transfer trip provisions on this site, which means, where's that tower? Now, anyways, we'll look at it when we get to the roof. There's a tower that communicates with Hydro One substation. If they have a problem on the load side, they can choose to disconnect the system automatically. So when that happens, you would get an alert from the inverter system saying, hey, we're offline. That's a point to reach out to Hydro One and say, okay, is there some problem? What's the issue? How do we get reconnected?
So they can disconnect off-site?
They can disconnect off-site.
Okay.
So it's a remote transfer trip.
Okay. And now, sorry, you said that there's no dead, like this is the emergency.
This is the emergency disconnect. So this switch here,
yeah.
you don't have to open it.
Okay.
You just turn it.
You just turn it.
Yeah.
Okay. That's
Yeah.
what I was wondering. If you open.
No. So the only risk with this is that somebody walking by might throw it, but the same thing, you'd get an alarm saying, hey, the solar's been turned off.
Okay.
And given the
So
location,
that is that way.
yep, it just spins. You see up here, if you come up closer, on is up top here, and then off is beside. So it just goes like that.
Okay. Oh, okay.
Is it a two-function lever? Do you have to do something with that red slip?
No, that's a bypass. So if you're going to do the infrared imaging and you don't want to turn off the system, there's a pin here you got to push, and then this is a lockout tag out. So if you've isolated, you can lift that and put a lock on it. But this actually just runs, just will operate. I won't do it, but
And
it's,
where does that alarm come through? On the BAS system?
No, it comes through the monitoring of the solar. So there's a separate platform for the solar monitoring.
Okay.
So we should definitely get somebody on site that has access to the solar.
Yeah, I think that's helpful, and I think also just a plan. We can talk offline after about who's managing, who's the point of contact.
Who do we contact?
Yeah, how that gets handled. So
When Hydro remotely disconnects, are they just disconnecting the solar or the whole building?
Just the solar.
Just solar.
That's a great question. Yeah. So if they have to disconnect the load, they would do that at the substation, and it would affect everybody on the feeder.
Yeah, gotcha.
But they can only handle a certain amount of generation on the feeder, and that's basically why. There's some large solar farms south of here. There's some other projects on that same feeder. There's some upgrades that are happening, like the substation right now, the Marysville one, is on a temporary substation, so they're going to have to transfer the loads over sometime in June or July, and we can work with you on what's involved. It's pretty easy, but we have to just coordinate with them once they've done that transfer. They want to retest that transfer trip.
So basically, it's not overloading the outlet to the street, right?
Yeah, it's not overloading at their substation. So if, let's say, there's a whole, drop in load, and all of a sudden there's too much generation, the voltage is rising too high at the substation, they can dispatch and turn off the solar to reduce that.
So what happens internally for us, for our building, if you shut it off at the street, but we're still generating energy from the power?
You won't. So that's a really important, good question. So the way that disconnect works, so this actually still hasn't connected into your building yet, and this is where they're basically isolating. There's what's called a contactor in there, and that trip will isolate the contactor. So it doesn't interrupt the building power, but it would interrupt the solar. So it automatically turns the solar off.
I'm not getting an increased energy bill from solar that's stockpiling here somewhere, right? Like,
No, so
Does it
if they turned it off and
override?
left it off for a couple weeks, you would see an increase in your electricity bill because it's not offsetting the energy. Does that make sense?
yeah.
So, but if they dispatch it and turn it off, it's not like a wind turbine where they have to throw it to a dump load or hydroelectric.
Yeah, okay.
It can stop, and it basically just leaves the power up there. It's kind of an interesting characteristic of solar. So if it's not connected, it'll sit in what's called an open circuit, and it'll just wait. Now the panels get hotter. They do run hotter, but it's not going to damage them, and it's just a loss of generation. So
It's still able to generate the signal.
exactly.
Whatever's there is going to happen.
Exactly.
It's going to nowhere.
Yeah,
Yeah.
it's sleeping. Yeah.
It's sleeping.
Yeah.
That's the way to think of it.
And
Yeah.
all the wires are still electric.
Yeah, so it's
electrified.
actually that brings up a really good point. So this system has what's called optimizers. So there's an optimizer which is like a DC interface for every 2 panels, and that optimizer provides both safety and optimum performance. And so what it does, if you turn that system off, the 600 volts actually turns off, and it will be 1 volt per optimizer. So instead of 600 volts, you might read 40 or 50 volts at the inverter, and that's because those optimizers are a safety device. So if there's any sort of emergency or fire, it immediately reduces the voltage down to basically the module voltage, which is about 40 or 50 volts. Think of it that way. So, now what that means is that there's a device under all those panels. For every 2 panels, there's an optimizer, and so sometimes they have trouble. Like when I looked at this on the weekend, there's one optimizer. There's about 430 optimizers across the site. There's one that was reporting having a difficulty, and so you will get some alerts like that. It's not something to panic about. It's just something that will need to either be reset or replaced under warranty if it persists. One optimizer down on a system this large is not worth calling for a service call. Once you've got a few or it hasn't been resolved, then that's when you do that.
So we're just gonna monitor that one?
I'll show
and-
you on the monitoring what it
Okay.
looks like. Yeah, so because this is a brand new system, we're going to stay on top of the contractor to get that
Okay.
corrected so that it's a clean slate. But generally, once you get into operation, there's going to be sometimes they pop up, sometimes they pop off. Some of it's a communications issue with the devices, like they're communicating along the power wire that's up there. And so if you see it trip out, it doesn't automatically mean it's a problem. It might come back the next day. But if it persists, then that's when you look to do something about it. So let's move back inside, and I'll we'll keep tracing where this power is going. So this is the emergency disconnect. Now we come into the building. So the power that went out the back of this disconnect goes in the back of the other disconnect. Then it comes back in through these 2, and that runs up into the switch gear to this breaker on the load side. So there's some clear labeling here saying that this is the DG, or our distributed generation. That's what the generic term for solar or wind or battery energy. So this is the interconnection breaker. They've added, just to make it really clear, that solar. We shouldn't have to do anything with this breaker. We don't use it for operating the system. That's done over there. But essentially what happens is the solar energy comes in now at 600 volts, and it basically flows to whatever breaker needs power. So if you've got, I don't know, let's say northeast wing pulling extra power, that power will come down, and because it's the path of least resistance, it'll supply those loads. Now if these loads are all satisfied, it will actually keep sending that power down, back over through the switchgear, and up through the metering section, and that's where the net metering starts happening. So you start getting electrons pushing back up and out to the grid. You don't have to control it. It does it all based on whether there's load or whether there's not load. So
that's extra power, like being pushed back out?
yeah,
Okay.
yeah. So like today we might be running around, I don't know, we'll pull it up like 250, 300 kilowatts, and the building's drawing maybe 120. So there'd be a couple hundred kilowatts going out and feeding back to the grid. And so what happens is you get those credits, but that energy goes to the house next door, or the community center down the road. Like, it gets used in the grid, but you get the credit that you can use then in future months. So it's part of the balancing of net metering. The credit, when you do cash it in, so when you guys are tracking your costs, you don't get a credit on the delivery charge, so there still is a delivery charge because they're maintaining the grid. But on the consumption portion of the charge, it would be credit that out. So it's not a monetary value, it's an energy value that then applies to that later month. Yeah. So that power comes in here, shouldn't have to do anything with that, comes down, and then it automatically flows. Now, because we wanted to keep track, so this project is under the GICB, and part of that was the Green Inclusive Community Building Program. They wanted zero carbon building certification for the design. So part of that is a track. Now, you guys may decide to certify for construction, but that's not part of the scope at this point. But we put what's called a net meter in here. So you have a check meter that talks to the solar platform. So you can know whether it's supplying or drawing from the grid. And it'll be a way that you can reconcile what you're seeing from the utility billing with what's actual. So there's a meter, it's actually up there, but the CTs and equipment is in this section so that you can record that. So that sounds more overwhelming than it is, but it's in there. So the last piece, so that's the power piece of it. Now we'll talk a bit about the communications piece of it. So this enclosure, and I'm going to get the ladder up because I need to open that box. So you should only have to get in this box if there is a problem or troubleshooting required. But this enclosure includes a variety of equipment. So there's a meter here that's validating energy, current flow. Again, you shouldn't have to worry about this. This is where the operator,
When you say you shouldn't have to get into this box, you don't mean us, right?
you guys will never have to. So
Okay.
it'd be the maintenance, it'd be like the solar maintenance staff if they have to go in. I just want to give you an overview so you know what's what. So the top right there is all Hydro One's equipment. So there's a real-time monitoring that communicates back to their operations center, so they can see what the solar is generating, current voltage, and how it's performing. There's a backup UPS in here just to make sure that if the power goes down, they still have some communication on it. And then there's a controller that is part of what they communicate with if they have to disconnect the system. So there's a separate antenna that runs up to the roof. But this is basically, think of that as the utility protection equipment. If you had to shut the system off because you're going to do maintenance or servicing, the softest way to shut the system off is this dial switch right here. Just turn it to the left and it will operate the contactor outside. I won't do it because we've got full output and it would be hard. You can do it safely, but it's not great to do all the time. If you do that though, when you turn it back on, there's a latching relay so that it doesn't turn on automatically. You've got to push the green button and then it will connect and start operating. If Hydro One does a remote transfer trip on us, basically the only way to get the system back running is to turn that switch and then turn it back on and push the green button. So, but they will, like, we'll figure out who the operating contact is. They'll call you if they have to do that and explain what the reason and everything is.
And that can be anytime, 24 hours a day, 7 days a week.
Yeah. Realistically, they won't call you when they do it. So you'll notice it on monitoring. If the system's totally off, that's the likely reason. And then you'll call them and say, hey, can we re-energize? We'll get a trial of this in the next month when they switch the substation over, because they'll just disconnect it and then they'll want to do testing again. So we can work with you to do the testing. It's very easy. Basically, you just call them, they check that everything's reading, and you listen for that operation.
So if Hydro One, if we came in and found a notice through the app or
Yep.
whatever it is saying that Hydro One did a disconnect, is this something that Gene or I could do without calling someone? It seems
No,
pretty
you
simple.
do have, it does seem simple.
Yeah.
So here's the thing, if you see it's off and you come and reset it, if they haven't enabled the circuit yet, it won't
Okay.
do anything.
Okay,
So the whole point is, the reason why there's a latch on this and it doesn't do it automatically is that you're supposed to call them, make sure they're ready, and then turn it back on.
but if we spoke to them and said, okay, we're gonna turn it back on
Yep.
here,
You could do it. Now be aware that in here is 600 volts, like it's not,
so it's probably better to call.
probably better to
someone.
call either your
Yeah.
maintenance solar or facilities.
Maintenance solar,
Yeah,
okay.
to deal with that.
So we'll have a maintenance solar person.
So I was talking with Tom about that. We can look at that afterwards. But yeah, you'll like your insurance is looking for a maintenance program and sort of an ongoing,
Okay.
supervision,
Yeah.
support, right?
Okay.
So, any questions about this? I know there's a lot in there, but the kernel of it is this isolation point.
And that's controlling that box up above it?
This is actually a
No,
UPS.
Sorry, the next box up in the.
No, so this is actually controlling the contactor that's outside.
Oh, okay.
The box, thanks for asking. The box up at top is just for the net meter that communicates with SolarEdge. So you should never have to go in there. It's been all configured. But that's just, they didn't have enough room to fit it in
So they
this
just
one.
pop it through the wall? Okay.
Yeah, yeah. So, yeah, so when I won't do it, but when you turn this, you'll hear kerchunk. That's the technical term outside, and that's the contactor opening up.
Okay.
And so that's how you know it's, so when you do the testing with Hydro One, all they have someone here for is just to make sure that it isolates. And so you'll hear that go off and you'll see the voltage drop, and they see it on their end.
So they'll come and actually test it and turn it off, Hydro One.
No, they'll call you.
Okay.
Yeah, but they just want to make sure when they enable it that it connects back in, so.
That's the four 600 and whatever volt.
Yes, that's the grid voltage. So you'll notice there, the nominal is 600,
Yeah.
right, 347. This grid runs a bit hot, so it's 620, it's on the higher end. Now, 620 is not crazy. Part of the reason that voltage is higher is because we're producing, I have to look at the monitor, but I'm gonna guess we're producing more power than what the building's using. And so it's,
Just
think of it
because we have
as,
more sun.
yeah, and think of it as pushing those electrons out. So as it's pushing the electrons out, the voltage rises. Now, it's not a problem until it gets like, up over 5 or 630, like then it'll start to break out.
635.
Yeah, it's like 10% basically. If it gets,
And there's a fail safe on that, right? If something happens.
yeah,
it'll
so
go-
the inverters typically, if they're operating, if they see something outside of 10% voltage, they'll disconnect.
They'll just-
If they're starting up fresh in the morning and they see something outside of 6%, they won't connect. So if the grid's running high, they won't connect and they'll give you an alert. They'll say an AZ alert, but that's all automatic. So all the protection control is all automatic. The same thing happens if for servicing the main breaker's turned off or the grid's turned off, the inverters will isolate automatically. So they won't try to connect to the grid if they can't see it. So it's a safety protection, it's called anti-islanding or C-standardized. And we've tested all that functionality as part of the approvals. We did that back in December. So we're confident in the settings and we're confident in how it's configured. Yeah, we have a single. Thank you. We have a single line posted here. So this is a simplified version. You'll see in the as-built drawings a bit more involved. But this is Hydro One's version. So this is on record with them. So very basically on this side, they don't really look at the DC equipment. So the panels and the optimizers, they don't care. They're basically looking at the AC side. And so we've got 4 of these groups coming through, feeding into these rooftop panels. And then this is the communications control. So that is the box that's outside. And then it comes in through those conduits to that breaker, which is sitting here. It's called DG1. And then it feeds back through to the switch gear. So that's the simplified view. I'll go over and we'll pull up the monitoring to get a look at that. Now SolarEdge has been tinkering with their portal, so it's been hit and miss, but it seems to be working well today. So basically, so there's this icon here, or this sort of graphics here. The thing to be aware, so this is the solar. So right now we're producing about 265 kilowatts. The building, or what's called the load, is using about 211 kilowatts. So you must have everything running, probably air conditioners, that sort of thing. And so we're actually still net exporting about 50 or 60 kilowatts. So it's producing enough energy that it's overproducing what the building's using, which is pretty common for the size of system that we have. What you have to think about is the building keeps using energy at night and on weekends, or not weekends, it'll generate on weekends, but at night, and so your load ends up being more. So this is not going to net out all your energy for the year, but it's going to take a substantial piece.
Now, would our exporting go lower though at night? And
Yeah, so what will happen is at night, this amount of production will go down to 0, and so then the exporting will reverse, and whatever the building's using will be drawn in as load. So it's kind of, once you get the hang of it, you get into looking at, what the generation is and the balance, you get a sense of it.
And how much is the solar supposed to offset through the year?
So according to the energy model, it's supposed to be at 80%. Energy models are notoriously variable, and so I like to say it's going to be somewhere between 60 and 80%. What the variance is not the solar. We're pretty good at predicting solar, but what the building's actually going to use. So generally buildings use about 20 to 30% more than the zero carbon energy model method applies. So it's significant, like 60 to 80%.
is what we're supposed to,
When you look at the end of the year,
yeah.
about 60% of all the electricity you use should be generated by the
From
solar.
Okay,
Yeah.
okay.
If it's much lower than 60, then we need to talk.
Okay.
The highest it would be is like 80 based on the model. There's a bunch of graphics here which are kind of fun once you get into it. Basically, let's see if I can unroll it properly. So basically, this kind of curve you see here is the generation curve. The 2 colors within it, so the one blue on the top and the turquoise, is basically just saying how much of the energy that's being generated from solar is being used right away from the building. And so if you look at the dark blue and the light green, they sort of mirror each other because the build consumption's on the bottom and generation's on the top. So it's basically saying that during the day, you're producing all the energy that the building needs, and then excess, so that's the top of that curve. And then at night, you can see the orange is just what the building's using, consumption-wise, and there's no solar generated. So if you think about total energy, it'll be the sum of this area under the curve and this area under the curve, and that's what you're trying to balance out. So let me think about how we frame that. So basically what they're saying with the graph that you see right here is that from a production standpoint, about 60% or 2/3 of the energy that's produced is used right away by the building, and then about 40% of energy is going to the grid as credits. So that's the ratio right now. It'll change time of year, but that's the kind of the mix right now. The other thing to keep in mind when you're looking at the monitoring is this 400 kilowatts is our peak output. So if you saw that curve peaking out below 400, say at 350 or 300, that's a pretty good indication if it's a sunny day that there's an inverter offline. So that's a chance to go look at the faults. If you look at a day like this, that was partly cloudy in the morning, and then it got sunny in the afternoon, and that's why that curve doesn't look quite the same.
So is that May 18th? Is that day?
Yeah, this is a
that-
3-day, so
Oh.
yeah, so that would have been Sunday. That was yesterday, perfect day, and then we're just starting up on today. Yeah, and there's different views here. It defaults to the 3-day. You can look at the 1-day. You can go back 1 day if you want to look at what that perfect day looked like. So yeah, I mean, I'll say looking at the energy numbers, consumption's a bit higher than the model said. Part of that was commissioning, getting things set up. Part of it's just the operation. And I think where the model might underreport is at nighttime the setback. I don't think the setback's as significant as it was modeled. So, or at all, as Mike was saying. So,
You don't really have setback, like they're to maintain at 22 degrees minimum and 24 maximum.
yeah. Are the airflows aren't adjusted at all? No. they're
Only
just
in the office.
CSA whole time. Yeah, the office.
Residents have to be kept
Maintained.
stable.
Maintained at 20.
Yeah, yeah. Good. So I'll just take you through a couple of things here. So this is sort of the dashboard. This dashboard, we can actually create a link if you want to post it on like a monitor in the hall display or something like that. So you can post it and see people can see what's happening, real time. There's a lot of data there. I think the monitoring link might be even a bit simpler, but it kind of gives you this idea. This is just saying, when you're up here, you're maxed out at the 400. This is an analysis. This is maybe more for operators if they want to do benchmarking on generation. We'll see if it does it. You can set up reports and trends to see how the system's performing. Yeah.
For MB2?
Yes.
Okay.
So they're working. Their portal's been under maintenance, so we'll try another one. This is alerts. You can also get this on a phone app. So if we set up access, I found the phone app is quite reliable. Like even when this display wasn't working, the phone app was pretty consistent. So here's one product isolation issue, inverter 5. But looking at the time, that happened back in December. So that's when we were doing the startup and commissioning. So that's something that's been was sitting there. I left it open just to show you what it looks like. That's a red alert. Basically, we can close that because the contractors addressed that. There was an issue with some of the strings not communicating properly, so that's been resolved. And then the other issue, which actually showed up on the 14th, so last Thursday, is this optimizer. So that optimizer 4.0.1, what does that mean? I don't know if they have it set up yet, but there's going to be an array map that physically maps out where the optimizers are based on the building. So let me see if they got that set up properly.
You said you had an alert on the weekend too, here? Does that show here?
On the 14th, there was one, yeah. So this one is no communication with the power optimizer. Pop that up there. So basically that means one of the optimizers under the panel just wasn't communicating properly with the other equipment. So it might self-resolve, although that's been, almost a week now. That was last Thursday. So this will be something that we'll give to the contractor to say, hey, that's the last thing to wrap up. Were they back for all the final panel replacements 2 weeks ago, I think? Yeah, they were back. So,
I think you said too, like you could do a reset with it, right? Like and try that once you take it over. So do we do the reset through the automation over it, or?
so the reset on the optimizer is actually at the inverter. And so doing what's called a repairing. So again, that's not something you guys need to hike up there and do, but that is something that your facility operator can do.
Will you be monitoring
Okay,
this
so
as
this
well?
hasn't been
Okay.
this hasn't been configured all the way yet. So this is kind of an electrical organization of the site. I'm going to try to zoom in here. Each one of these. So this needs to get populated on the roof plan, and that's still an expectation the contractor will do. So what they did is when they installed, they took a barcode off each individual optimizer and plotted it on a grid, so you know which roof it's on, so that if you're troubleshooting, you're not going around all of them. But basically, this shows you the idea. Each inverter is here. There's 8 total, and then the optimizers within it. So this is where you get an alert. So this is the one that's flagged as having an issue. It's not very helpful in this view, but when you see the roof plan view, then you'll know physically where it has to be addressed. Any other questions about alerts or?
I guess that alert, yeah, you could narrow right down to
Yeah,
the
so
area on the rooftop or home area.
you can see here there's open alerts, so it's an open alert, hasn't been addressed, but it's not deemed a high impact. So high impact alerts are like a whole inverter's off, or there's some kind of fault that needs to be investigated right away. So you might see, like we have sites, we work with the city of Belleville, they have a site where like it gets to like 6 or 8 issues, and then they'll roll a truck to take a look and repair it. So there's a lot of optimizers, so it takes a bit, it doesn't make sense to get someone out every single time. But it's kind of a judgment call, because sometimes that's not actually, it might still be running, it just might not be communicating, right?
I guess it's the domino effect of it, like this piece here is affecting first pieces behind it.
Yeah, so if that was to happen, so that can happen, if let's say an optimizer burns up or shorts out, right? It can break that whole string. But then you'd see a high impact alert, because it would have a whole string off.
Okay.
Yeah.
Great.
This system, I mean, you're dealing with energy and energy generation, but this system is probably the safest in that if there's a fault like that, it'll isolate that panel from the rest, so you don't get a fault that affects all the panels. So there is the possibility that it might impact that whole string of panels, but more often it'll just isolate and then operate. Let's see. So this will be in the as-built package. I don't know, do we have the O&M manuals from Triumph yet?
Yes.
Sent this morning.
Oh, sent this morning. Okay, let me pull that up a second.
You close the door.
Oh, that door? Yeah.
Okay, while we're finding that. So this is the more involved single line. Again, not that you guys need to worry about it, but it's got more of an as-built indication of the inverters and the equipment. This is the bonding, wiring details. There's some construction details. So this, we'll take a look, but those of you who maybe aren't going to the roof, this is kind of a inverter group that you'll see up there. So there's 4 of those inverter groups. Each one of these inverters is 50 kilowatts. And so each inverter feeds to a disconnect switch, which then connects to a splitter, so that combines that power. And then it gets stepped up through the rooftop mounted transformer. So these inverters are 480 volt output. Probably one of the most common voltages for inverter-based equipment, mainly because Canada is a relatively small market worldwide for solar. We have an isolation transformer that then steps it up to 600, which is the grid voltage. And then there's a shut-off disconnect that will take that whole group off. So it's the first one you walk up to when you get to the roof there. So if there ever was an issue and you're up on the roof and something doesn't look right, that main rooftop disconnect will isolate basically that whole group of equipment. So that's up there for isolation. From this run, that's where this comes all the way back uninterrupted to those cables that you saw. So for any rooftop work that's happening up here for like infrared imaging or maintenance servicing, they have an isolation means up there. They can lock out. They'll still need access to get into here, but it just makes it a little more like better proximity. So this is repeated 4 times, 1 for each wing, essentially.
Can you take a picture? Can you zoom that in again? Can you take a picture of that?
Oh yeah, sure.
Thanks.
All right. construction details will be reviewed over there. So yeah, I think we can take the tour up to the roof now, for those of you comfortable with that. The stair tower is still accessible, so we'll use that.
Any PPE up there? We're okay with that?